Hello, everyone. Today we're going to be talking about why transistors are the greatest achievement of the 21st century. My job was to make the task and the timeline help research and along with the bibliography. After this, Miguel made a list and criteria of why the transistors were the greatest engineering achievement. Christian helped with the justification of this. After this, Caleb described and explained what the transistors did and how they worked. Ryan, after this, helped with the pros and the benefits of why they're so helpful and how they help us in our day-to-day life. After this, Christian will help with the completion check, and Miguel and Ryan will both help with the editing and submission of the YouTube link. This is the timeline I made to help people keep on track and make sure they stayed ready with all their.
Why are transistors the greatest achievement of the 20th century? John Bardeen, one of the founders of the transistor, said, "In 25 years ago, it would have been impossible to imagine the remarkable developments that have since taken place in semiconductor science and technology. Transistors were a revolutionary invention because it combined discoveries from the semiconductor field with those of solid state physics. Before transistors, vacuum tubes were used for powering radios, telephones, amplifiers, etc. Vacuum tubes were bulky, not very efficient as they required too much power and they had the issue of burning out. Down here, we can appreciate the difference of both. Application of transistors. Lilienfeld invented the concept of a field effect transistor. He believed that applying a voltage to a poorly conducting material would have changed its conductivity and thereby achieve amplification. This type of transistor invention by Lilienfeld was ahead of his time. It was first patented in 1926, but had no use in the current state of engineering at the time. Field effect transistors are nowadays used as switches in chips or microchips. If we use the analogy of a building, transistors can be thought of as one of the pillars. Transistors created a domino effect. Transistors led to integrated circuit technology, which then led to microcontroller technology. Some applications of integrated circuit technology and microcontroller technology, where transistors play a fundamental role, are power, microwave, and small signal amplifiers, radio receivers, voltage regulators, calculator, memory chips, temperature sensors, robotics, or health monitoring systems, in between others.
What is a transistor? Very briefly, a transistor is a device made from semiconductor materials used to create logical circuits. There are many other ways to form digital circuits, but transistors have huge advantages compared to other technologies like vacuum tubes, as we've already touched upon. What are they used for? Transistors have many applications today. They're used in all sorts of miscellaneous electronic devices and gadgets, essentially anywhere you need digital logic. Most importantly, they're the building blocks of modern computers, including personal computers, laptops, smartphones, etc. Transistors are getting smaller. Since invention, transistors have rapidly shrunk. In fact, there's an observational law called Moore's Law, named after Gordon Moore. In short, the law states that the transistor density on microchips doubles about every 2 years. This progress has slowed somewhat, but has largely held true since the 1960s. Why is this important? In general, the power requirements of a microchip is proportional to the area. As transistors get smaller, you get more complex circuits and faster computation for approximately the same power use. In short, smaller transistors mean faster computers, less heat production, and better power efficiency. This is especially important for mobile devices. A modern smartphone would have been impossible to build a couple decades ago. Even if you discount power and heat concerns and everything else, there would still be hard limits that force microchips to stay under a certain size. Most modern personal computing devices have a clock speed of several gigahertz. The exact definition of clock speed isn't important here. All that matters is that there's something happening every few hundred picoseconds. The distance light could travel in 100 picoseconds is only about 3 centimeters. This means that if you want a computer processor to stay synchronized, you can only make your microchip so big before you bump into true physical limits. Therefore, for many reasons, the only way to pack in additional circuits into a microchip is to increase the transistor density.
For the societal benefits, transistors brought portable, fast, and efficient electronic devices to the public. Transistors drastically changed the social environment, and without transistors, our communication cross-country and globally speaking was slight. This has allowed society to communicate, inform, learn, and socialize at a global scale. For the unintended consequences, modern transistors are applied to space equipment to check for levels of radiation on satellites. This is truly a testament to the seemingly endless applications of transistors.
So why are transistors the best? Well, here's three quotes that I think summarize it perfectly. The first one states, "We've become a society completely reliant on instant access to information, and it's all thanks to a little invention called the transistor. Things such as smartphones and the internet would not be accessible to the average person if it was not for the transistor." The second quote states, "Transistors have become one of the basic building blocks of modern technological life. Breakthroughs in things such as medical advancements, space exploration, and globalized connectivity are all thanks to the transistor." And this last quote, which I think best summarizes the importance of the transistor, states, "It's impossible to overstate the impact that personal computing has had on our modern world, and all of that innovation is only possible due to the invention of the transistor."